Chapter 8 Algorithm and Flowchart. Computer, as you know, is a machine. It works on our instructions. We need to give stepwise instructions to the computer in a proper sequence to make it do a given task or solve a problem. In this chapter, we will learn how to give stepwise instructions to solve a problem. Algorithm. An algorithm is a sequence of steps written in simple language to solve a specific problem. It is a representation of a solution to a problem. Algorithms are essential to the way computers process information because a computer program is essentially an algorithm that tells the computer what specific steps to perform, in what specific order to carry out a specific task, such as calculating the total of the amount to be paid by a customer at the grocery store or printing the report cards of students. Rules for writing algorithms. Here are some basic guidelines for writing an algorithm. 1. Give stepwise instructions, numbers as step 1, step 2, etc. 2. Always begin with the keyword start. 3. Write each instruction in a separate line. 4. Function of each statement in a separate line. 5. Write stop at the end of the algorithm. Writing algorithms. In our day-to-day life, we perform a number of tasks that require us to follow a stepwise approach. Let us have a look at some of them and write the algorithm to perform them by enlisting all the required steps in proper sequence. Example 1. Write an algorithm to buy a chocolate from the market. Step 1. Start. Step 2. Think of chocolate you like. Step 3. Get some money. Step 4. Visit a shop. Step 5. Buy chocolate. Step 6. Return home. Step 7. Stop. If you look at the above example carefully, you will notice that we cannot change the sequence of steps, like we cannot buy chocolate without taking money or return home without buying chocolate. So, to use algorithm technique for solving any problem, remember to arrange these steps in logical order. Let's now see a few more examples. Example 2. Write an algorithm to prepare a cup of tea. Step 1. Start. Step 2. Take water, sugar, milk and tea leaves in a container. Step 3. Boil the contents. Step 4. Pour tea in a cup. Step 5. Stop. In earlier classes, we have learnt that the computer works in 3 different stages: input, process, output. We can also relate the tea making steps in the above example to input, process, output cycle. Let us see how. Step 1. Start. Step 2. Take water, sugar, milk and tea leaves in a container. Step 3. Boil the contents. Step 4. Pour the tea in a cup. Step 5. Stop. Example 3. Write an algorithm to find the sum of two numbers A and B. Step 1. Start. Step 2. Input A, input B. Step 3. Let C is equal to A plus B. Step 4. Print C. Step 5. Stop. For solving a complete problem, algorithms are often broken down into smaller chunks called or sub-procedures. This is done as smaller algorithms are easier to read and also because then parts of the algorithm can be reused. Advantages of a algorithm. There are many advantages of writing algorithms for solving any problems. Some of them are as follows. 1. They are easy to understand. 2. They are easy to implement. 3. They describe the steps that should be taken to solve a problem. 4. They help to eliminate any errors in our problem solving logically. 5. They are independent of any computer language. 6. They can be easily converted into flowcharts and then into computer program. Flowcharts. A flowchart is a diagrammatic representation of an algorithm. This graphical representation plays a vital role in the programming of a problem and is helpful in understanding the logic of complicated and lengthy problems. Once the flowchart is drawn, it becomes easy to write the program in any high-level language. Flowcharts are usually drawn using some standard symbols, which are terminal box. The terminal box is an oval-shaped box which shows the beginning and the end of the flowchart. Each flowchart can have only one beginning point and only one ending point. In the beginning of the flowchart, start is written and at the end, stop is written in the terminal box. Input-output box. The input-output box is used to show input data and also output for the result. This box is like a parallelogram in shape. For showing input data, input or get keywords are used in the box, and for showing the result or output words, print or display is used. Processing box. The processing box is used to show the processing work. It shows calculations. This box is rectangular in shape. Decision box. The decision box is diamond shaped and is used to check some condition or compare two values. Each condition can have two answers, yes or no. This box has two exit points and one entry point. Flow lines, arrows. All the flowchart symbols are connected to each other by using the arrow-like shapes called flow lines. Remember, only one flow line can exit or enter the start and stop boxes respectively. Connectors. The connector in a flowchart is used for continuing a long flowchart on another page. It is also used to jump the normal flow of a flowchart. The connector is given a name which is written in the center. Let's convert the algorithm of preparing a cup of tea to a flowchart. Start. Take water, sugar, milk and tea leaves in a container. Boil the contents. Pour the tea in a cup. Stop. Flowchart to prepare a cup of tea. Flowchart for finding the sum of two numbers is shown below. Start. Enter numbers A, B. Sum is equal to number A plus number B. Display sum. Stop. Flowchart to add two numbers. Here are some more examples on algorithm and flowchart. A. To display your age. Algorithm. Step 1. Start. Step 2. Input age. Step 3. Display age. Step 4. Stop. Flowchart. Start. Input age. Display age. Stop. B. To display the product of two numbers A and B. Algorithm. Step 1. Start. Step 2. Input A, B. Step 3. Calculate product is equal to A into B. Step 4. Display product. Step 5. Stop. Flowchart. Start. Input A, B. Product A into B. Display product. Stop. C. To display the average of three numbers, say A, B, C. Algorithm. Step 1. Start. Step 2. Input A, B, C. Step 3. Calculate average is equal to A plus B plus C divided by 3. Step 4. Display average. Step 5. Stop. Flowchart. Start. Input A, B, C. Average A plus B plus C divided by 3. Display average. Stop. D. To compare two numbers A and B and display the bigger number. Algorithm. Step 1. Start. Step 2. Input numbers A and B. Step 3. If A is greater than B, for display A. Step 4. If A is less than B, display B. Step 5. Stop. Flowchart. Start. Input A, B. Is A greater than B? No. Display B. Display A. Yes. Stop. Advantages of using flowcharts. It is usually much easier to draw a flowchart of a problem and then to write the program directly. Flowcharts are an important aid in the development of the algorithm itself. They are easier to understand than a program. Flowcharts are independent of any particular programming language. It saves the time in writing a program. It saves the computer time. Sum up. An algorithm is a sequence of steps written in simple language to solve a specific problem. An algorithm is a logical and stepwise representation of a solution to a problem. A flowchart is a pictorial representation of an algorithm or sequence of steps involved in solving a particular problem. The flowcharts have some special boxes to show different operations. Every flowchart should have start box as the first box and stop box as the last box. Every flowchart must have only one entry point and one exit point.